Your learning journey starts now. Ever felt like some problems are just stubbornly hard? Like, you can check an answer super fast, but finding it? Nightmare fuel. That's the P versus no problem vibe. We've been told it's about time on a fancy machine, but what if the real puzzle is hidden in meaning? Forget just counting steps. Let's talk about understanding. So, how do we understand meaning? Enter DIKWP. Think of it as layers of understanding. At the bottom, data, pure raw stuff, like sensor readings, all the same. Then information, we spot patterns, differences emerge, like seeing a cat in pixels. Knowledge, we organize it, make it complete, rules and facts. Wisdom, we get the big picture, structural insights, strategy. And finally, purpose, the why, the goal, driving it all. Crucially, these aren't separate boxes, they jump back and forth. This interconnectedness is key. Okay, here's the kicker. No problem, problems are tough because they live mostly in the information layer, full of complex differences. Think SAT clauses, TSP roots, graph edges, tons of unique constraints. The semantic idea is radical. What if we could compress this messy information back down to the simpler data layer? By using our semantic understanding, the knowledge, wisdom, purpose, we find ways to represent the problem differently. We identify equivalent structures, merge things, simplify the constraints. It's like finding a secret map that makes the maze walkable. Let's peek at examples. For SAT, instead of blindly trying every variable combo, we look for clauses that imply others, or groups of variables that always move together. We merge them, reducing the apparent complexity. For TSP, if cities cluster geographically, maybe treat each cluster as a single point initially, then refine. For graph coloring, recognize symmetrical parts of the graph, solve one type, apply it everywhere. See the pattern? We take the chaotic different mess of the no problem and boil it down to manageable same patterns, making it feel like a P problem. Now, how do we navigate this compression? Using something called semantic tension. Think of it as the problem's stress level. How many rules are broken? How far from the goal? Our solver constantly tries to reduce this tension. But sometimes, you hit a wall, a local minimum. What do humans do? We get stuck, frustrated, then maybe try something completely different, a leap. Duan calls this BUG awareness. Recognizing the dead end, the bug, allows the system to intentionally expand tension temporarily, jump out, and find a new path. It's like admitting you're lost, taking a detour, and finding the exit. This mimics human intuition and is crucial for escaping no problem traps. This isn't just theory, it connects to famous math puzzles. The full color theorem proved by finding unavoidable configurations, essentially compressing infinite maps into a finite set of cases. Goldbach and Collatz. Easy to check individual cases, but proving the general rule. That's the no problem like hurdle. Maybe we need a deeper semantic insight, a new way of looking at primes or sequences. And yes, Godot reminds us some truths might be fundamentally beyond any given system. But the core idea is powerful. P equals no problem might be less about inherent impossibility and more about limitations of our current formal symbol crunching approach. Perhaps the solution lies in embracing meaning itself. Food for thought, right?